Hello, my amazing math students. This is Mrs. A, and I love math. And today we're looking at 91A in our Saxon Orange Book. We're going to split 91 into two parts because the second part is spheres and it really doesn't have anything to do with the first part. So we're going to split it up just to have a little bit shorter lesson here. So multiplication property of inequality is really cool. It's pretty easy if you remember one little trick. So when we're talking about the inequalities, when A is greater than C or B or whatever, instead of an equal sign in between, we have a greater than or equal to or a less than or equal to. Our inequality signs, greater than, less than, greater than or equal to, less than or equal to. And whenever we have those, it's almost the same rules as an equation, except for an exception that we have to remember. So the addition rule is easy. The addition rule, if we have A is greater than C, so the left side is greater than the right side, and then we add the same quantity, and here it doesn't matter whether the quantity is positive or negative, it doesn't matter. The left side will still be greater than the right side when all we've done is add a B to both sides. So that's really pretty much the same as the additive property of equations. Multiplication is the same if we have a positive number that we're multiplying by. If we start with A is greater than C, left hand is greater than right hand, and we multiply by a positive number where B is greater than 0, then everything stays the same. AB is greater than CB because we just multiplied both sides by the same positive number. So far, so good. Now here's the rub. If we multiply both sides of an inequality by a negative number, everything goes sour. We must flip the inequality sign in order to keep truth. So here's what I'm saying. If A is greater than C, then AB, when B is a negative number, must be less than CB. You say, what? Let's take an example, okay? Let's start with 5 is less than 6. Now we know in the number line, let's look at our number line. Here's 0, and here's 5, and here's 6. We also know that on the opposite side of the number line, this is negative 5, and this is negative 6. So, whereas 5 is less than 6, negative 5 is greater than negative 6. That's where the problem comes. So let's suppose I took 5 is less than 6, which is true, and I multiplied both sides of that inequality just by a negative 1. That's all I did, just multiplied by a negative 1. Now I have negative 5 is less than negative 6, and that is not so. Negative 5 is greater than negative 6. So to keep the truth, because don't you see how this back side, this negative side, is kind of a mirror of everything that's happening over here? So if a number is smaller than another number over here, the negatives of those numbers switch, don't they, in their order. So negative 5 is now greater than negative 6. So here's my rule. When I multiply an inequality by a negative number, I must flip the sign. That's it. I just must flip the sign in order to keep the inequality true. That's all. Right, so now we're just going to graph these solutions. This is a pretty easy section. Negative x is greater than or equal to 2. Okay, now, I don't want negative x. I want x. So what I'm going to do is I'm going to multiply both sides by a negative 1. So if I multiply this side by a negative 1 and this side by a negative 1, then won't I get a positive x now? because negative x times a negative 1 is a positive x, and that's what I want. So I just multiplied by a negative, so this is my little symbol that something's got to happen to my sign. So it was greater than or equal to, so now it's going to be less than or equal to. So now on the left I have x, and on the right I have a negative 2. So x must be less than or equal to negative 2. Domain is reals. And now that I have x by itself, I put on a 0, I put on my negative 2, x must be less than or equal to negative 2. It's going to be a closed circle going left. And now that I have an x instead of a negative x, it's much easier to graph. You never want to try to graph it when there's a negative x. It's difficult. All right, on this one, this is the second example. I'm going to have to be very careful because notice that my domain is integers. So I'll just be drawing little balls instead of a line like we just did on the last one. So here, 4 minus x, there's that negative x again. So the first thing I'm going to do is let's go ahead and get rid of the 4. So we're going to subtract a 4, subtract a 4. Remember, I can subtract or add all day long without changing my sign. So that's going to cancel out. I'm going to get negative x is less than or equal to 2. Okay, so now I'm going to multiply both sides by a negative 1 to get the x by itself. But since I multiplied by a negative, I will flip my sign. It was less than, now it will be greater than. And now this is a negative 2, and now this is an x. So x is greater than or equal to negative 2, where the domain is integers. So here's my number line, and here's my 0, and here's my negative 1 and my negative 2, and x is, we need to put a few more here. Okay, so x is greater than or equal to a negative 2. And only the integers work. So greater than or equal to a negative 2. And then greater than moves this way, but only on the integer values. And of course that pattern is going to continue on, but that would be my answer for example 2. Example 3. Again, we have a negative x. So we're going to go ahead and get rid of the constant. So negative 4 to the other side. Negative 3x, this goes out, less than or equal to 13 minus 4 is 9. Okay, so now I've got a negative 3 here. In all the others I had a negative x, but now I have a negative 3x. I'm going to get rid of the negative 3. So I'm going to divide by negative 3. Divide by negative 3. But remember the rule is if I multiply or divide by a negative number, I must flip the sign around. So now I have x. I have to flip this sign is greater than or equal to, and then negative 3. So when I'm graphing it, now this one is on the reals. So here's 0, negative 1, negative 2, negative 3, 1, 2, 3, x is greater than or equal to negative 3, and it's reals, so it will be the whole number line to the right. Aren't those easy? All right, here's our first practice problem. So copy it down and pause your video and see if you can do it on your own. All right, so hopefully you did that. We're going to have to get rid of the negative on the x. So we're going to multiply both sides by a negative 1. So negative x times a negative 1. And we're going to have to flip that sign around, so it's going to be less than or equal to 5 times a negative 1. So I multiplied both by a negative 1 and flipped the sign around. So this becomes x less than or equal to negative 5. The domain is the real, so the whole number line will work. That is, okay, so here, since this is less than a negative 5, I'm going to move my 0 over a little bit. Negative 1, negative 2, negative 3, negative 4, negative 5, less than or equal to. So here's less than or equal to is going to be a solid and to the left. Now, I don't have much space here, but this goes off to negative infinity, doesn't it? All right, so it's less than a negative 5, so it's just going to keep on going all the way to negative infinity. Here's problem B. 2 minus x is not less than or equal to 1, domain integer. So I want you to copy that down and then pause your video and go try to do it on your own. Okay, the first thing I'm going to do is get rid of this 2 because I'm trying to get the x. I'm working my way to get the x by itself. So subtract 2, subtract 2. So then we have negative x is not less than negative 1. Okay, now it's very difficult to deal with a not less than sign. It's not less than or equal to. If it's not less than or equal to, then it must be greater than. Okay, so we're just going to rewrite it. Negative x is greater than negative 1. Now we haven't taken care of the negative x yet. We've just taken care of this awkward sign. If it's not less than or equal to, then it is greater than, because it can't be equal to, can't be less than, it must be greater than. So we've simplified the sign a little bit. We at least know what that means, right? So now we need to get the x here instead of a negative x. So we're going to multiply by negative 1 and multiply by negative 1. And when that happens, we must flip this sign. So now this greater than will become a less than, and this is an x, and this is a 1. So x is less than 1, domain integers. Okay, so now when we're drawing this line, let's see if I can make a line down here. Okay, here's a 0. Here's a 1. Let's make this a 1. It's a very small one, isn't it? Okay, there's my 1. X is less than 1. So since it's less than, won't it be an open circle going to the left? So an open circle at 1 going to the left. Oops! What did I fail? I failed because that's integers. Let's retract. Retract. I'm going to come down here. I'm going to erase this because I need some more. That's not right because it's integers. So let's go. X is less than 1, domain integers. So let's draw it right here. So here's 0. Here's 1. X is less than 1, so it's only the integers. So 1 can't be marked. 0 can be marked. Negative 1 can be marked. Negative 2 can be marked. Negative 3 can be marked. So it's the same as what we just did, except instead of an open circle here, since we're only doing integers, and since it's less than 1, we have to start at 0 and start marking the integer values. Isn't that cool? Last practice problem for the first part of 91. And tomorrow we'll do 91B so that you get the whole lesson. But practicing these is probably enough for right now. Negative 3x plus 5 is greater than 1. So let's first get rid of the 5. So we're going to subtract a 5. And over here on this side, we're going to subtract a 5. So we have a negative 3x. This goes out, is greater than a negative 4. 1 minus 5 is a negative 4. Domain is integers, so let's remember that. Now we've got to divide by a negative 3. Divide by a negative 3, divide by a negative 3, and flip that sign around. So now we have a less. X is less than positive 4/3. Okay, so let's think about how we're going to do this. We're only dealing with integers. So here's my number line. And here is 4/3. Now 4/3, remember, is just right to the right of 1. Here's 1. And here is 0. And here is negative 1. And here is negative 2. And so forth. But we're only dealing with integers, and x is less than 4/3. So we can go ahead and bubble this one in because it is less. 1 is less than 4/3. And bubble this one in and bubble this one in because we're going to bubble all of the integer values. And of course, there's no way we can do them all because they go off to negative infinity. And that is inequalities in a nutshell. And this is Mrs. A, and may God bless your day.